Good afternoon, everyone. If you don't mind starting to take your seats, we'll get started in just a couple seconds.
We're good to see you.
All right. Well, thank you all so much for coming out here today for our PSI Mashup event. We're super excited today to have several excellent speakers. We're going to be talking about regulatory science today. So first of all, my name is Kathleen Denya. I am the Director of Innovation Partnerships for the Plant Sciences Initiative. And so today we're going to have these excellent talks. But I do want to go through some programs and let you know about some events that are coming up before we start. First, I also really want to thank our sponsor for this event, who helped with providing the food and drink, ClinLab Staffing. So please take the time to go. They have a booth set up in the lobby. Please go stop by and say hi to them and thank them for their support of this event. All right. So Mashup events, the whole idea behind Mashup is that we have one industry partner that's chosen as our spotlight industry partner for the session, and they are offered to give a presentation. So this time, Bayer is our industry partner of focus. And so these are industry partners that are members of our Innovation Hub in the building. If you haven't seen the Innovation Hub, it's on the 3rd floor of the building. I'm happy to take you up there. It's our spot in the building where we invite companies to join as members. And if they're members, anybody from your company can work from that space. And also that space is used for interactions between the faculty, students, and the employees from the companies. So really happy today that Bayer is our company of focus. And we also thank the other members of the Innovation Hub, which are shown here on the slide. All right, so get your cameras ready if you want to have pictures taken of some of these slides. Also, I can provide them to you after. But we do have several really exciting upcoming events. One that is going to be coming up on November 12th is our next Mashup session. So if you already want to go ahead and RSVP on Eventbrite, go right ahead. So it's going to be focusing as our industry partner, Novonesis. And we're going to have speaker Dr. Gregory Maloney. He's going to be talking about enzyme and microbial biologicals application development. So that's what his role is at Novonesis. And we're also going to have a speaker from the PSI. His name is Dr. Cameron Hunter. He is a postdoc in Amy Grundon's lab, and he'll be talking about this collaboration, which is called the Biocatalyst Interactions with Gases collaboration. So please go on and sign up if you're interested to join this event on November 12th. It'll again be in this room from 4 to 5 seminar. And then 5 to 6 will be another mixer. Another great event that's coming up is the Emerging Research Showcase that's being hosted by the College of Agriculture and Life Sciences. The topic for this ERS is going to be From Genomes to Phenomes, Ensuring Sustainability Amid Rapid Environmental Change. If you are interested in this, it's going to be on November 6th. It's actually going to be up in RTP at the NC Biotechnology Center. So for some of you might be a little bit more convenient located. Hope you'll be able to make it to the Biotech Center. It's from 3 to 6. And if you have any questions, you can contact Deborah Thompson. Deborah's over here in the back also. You can hunt her down and she'll tell you more about the event. Also, since we have several graduate students who had registered for this event, I want to make sure that they are aware that there are several really exciting opportunities that are currently available for them. One is on November 21st. We're very thankful that BASF is going to be hosting a visit of graduate students and postdocs to their sustainability center. So if you're interested in signing up for that, you can talk to me. QR code's here, and there's also a rotating screen out in the lobby that has the QR code as well. Another 2 opportunities that are coming from a very generous gift from International Farming. These are 2 student opportunities that come with funding. One is a graduate student outreach and engagement program, which provides $4,000 to support graduate students who want to be involved in this program. And then another one is our the International Farming Entrepreneurial Graduate Student Support Award. So this one's very interesting, exciting. This is open to any graduate students across the whole entire university. And it's for students that have an interest in, if they have an entrepreneurial idea in the ag tech realm, if they would like to apply for some funding to help get their idea off the ground. So in total, this award's for $9,000. And so they'd be pitching their idea for if they have a particular technology they want to commercialize, whatever their idea is. And from there, this would be a total of $9,000 to help them with getting this idea off the ground and provide them with some financial support as well for their program. All right. From here, I would like to introduce our executive director, Dr. Adrian Percy, to come on up and say a couple words before we start our session.
Thank you. And it'll only be a couple because you've given me 60 seconds, but I just wanted to also extend my welcome to NC State. For those of you who are visiting for the first time the Plant Science Building, first of all, well done for getting through our parking system. You are really heroes for doing that. But I see many, many faces that have come from multiple events here. So again, we're very, very happy to have you back. I think you know a lot about what the PSI is doing in general in terms of interdisciplinary research. So I'm not going to give you my usual spiel, but I will say that one of the things that we're very proud of and that we really try to emphasize is a role of being a convener and bringing together groups with different backgrounds that perhaps aren't always finding it easy to get in the same room. And so today I'm especially happy with CERSA to be doing this because they're real experts at bringing together industry, academia, and also government. And that's a group that doesn't always get together probably enough in my view. For those of you who know my background, you'll know that for my sins, I was a head of regulatory science of a large organization in the past. And I learned a lot of things about regulatory. I know it's very, very difficult. It's very challenging, particularly in today's environment where there are a lot of pressures coming from different angles on the regulatory services and systems. It makes it very hard if you're working in a regulatory and government affairs organization. It's also challenging if you're working on the industry side. So anything we can do to bring folks together, I think, is important. The other thing I would say is that regulatory, by its nature, is always going to follow somewhat the science. And the science will be out ahead in many cases of the regulatory systems and strategies that need to catch up. But I think that's particularly apparent today. You know, we're in a world where science is increasing exponentially. The opportunity of precision agricultural tools and new types of biologicals, for instance, is meaning that the regulatory system really has to play catch up continuously, which is a challenge for everybody. And so this event, I hope, will help us bring these groups a little bit closer and provide some more transparency about, you know, where academia is coming from, where industry is coming from, and of course, where government is coming from. So with that, I'm going to hand over to our first speaker, I think. Yeah. So it's Dr. Amanda Pierce, who's with the EPA. We're very lucky to have her as a local resident from Kerry. So very happy to have you back, Amanda. Thank you.
Okay. Okay, great. Yes, thank you for that introduction, and also happy to see quite a few familiar faces in the group today. So my name is Amanda Pierce, and I'm with the Emerging Technologies branch in the Office of Pesticide Programs at the EPA. And I'll be discussing a lot of the work that we, along with USDA and FDA, are trying to do as a way to modernize the regulatory process. So first of all, what is the biotechnology regulatory policy in the United States? In the United States, we believe that regulation should be science-based, risk proportionate, and based on the product. So not necessarily the process in which the product was made. Because of that, we're using our existing laws to give us the necessary authority to regulate these products. And I'll get into that more on the next slide. That also means that agencies have separate responsibilities, and we really try to coordinate as necessary. And that also means that the regulatory status of a product with one agency doesn't impact its status with another. So what that means in reality is that one product very likely is going to multiple regulatory agencies and is undergoing review at various regulatory agencies. So what we call this approach is the coordinated framework for the regulation of biotechnology, and it's EPA, USDA, and FDA, and we're all using our existing statutes. So at USDA, they're looking at products of biocontrol under their Plant Protection Act, so determining whether or not this product is going to pose any plant pest risk. FDA is, of course, looking at food safety, and at EPA, at least the office that I'm part of, we're in the pesticide group, so we're using the pesticide law to determine if that product is likely to pose any environmental risk, but we also look at the food safety aspect. So let me just give you an example of how one product would be regulated. Let's say you've got an insect-resistant corn trait. Probably a few people in this audience have had experience with that. So that type of a trait, well, you've hit the US government trifecta and you're likely going to all three regulatory agencies. So the trait will be evaluated by USDA and the plant as a whole to see if it poses any increased plant pest risk compared to the comparator. At EPA, we're really focusing on the pesticidal trait itself to see if there's any gonna be a risk to the environment and to make sure that the protein, for example, that's being produced is gonna be safe for people to eat. And at FDA, they're not looking at the trait itself, they're looking at the rest of the crop. So checking if this corn composition is equivalent so that it's as nutritious as conventionally bred corn, for example. Just to give people a further example of the types of products that typically come through my office, it's quite a wide variety. So we've got what we call the plant incorporated protectants. That's all the GE crops for insect resistance, disease resistance, that sort of thing. But we're also looking at topically applied dsRNA, topically applied peptides, genetically engineered microbes when they're being used as biocontrol, and we're also looking at genetic modifications in animals for population suppression. So that can be like Wolbachia-infected mosquitoes or the GE mosquitoes. Now, Adrian raised a great point about the increasing speed of innovation, and that is absolutely true. We're seeing a big influx in the number of submissions that we're receiving. This past year, the biopesticides division, the one that my group is housed in, I think had a record-breaking number of new active ingredients registered, and there is still a long queue to be registered as well. So then I think that means that as regulators, we really need to take a look at what this regulatory system is, considering the massive influx of new AIs that we're facing. So why is the regulatory system important and why is modernizing it critical to agricultural innovation? So in order to have a successful product, you need to have three things. A product that works, of course, a product that consumers are interested in, but also the policy environment needs to be such that that product can actually get to market in a reasonable and cost-effective manner. You might have a great idea and a product that everybody wants, but if it can't get through the regulatory system, it really doesn't mean anything. So with that, the last couple of years, we had a new executive order come out. Most administrations like to have a biotech EO, it seems, and so this is this one's. And it's the executive order on the bioeconomy. And so with that EO, the three regulatory agencies came together and we have various commitments that we've made. We've committed to increase the coordination across the US regulatory agencies. And I just have to say that in the 7 or so years that I've been with the agency, I do believe this past year, I have seen more meaningful and substantial collaboration and coordination across the three agencies than I ever have before. So I am hopeful that this time we will actually see meaningful progress. As part of that coordination, we're having conversations about reducing or eliminating duplicative oversight. And like I said, with that massive influx of active ingredients, we know we've got to increase our regulatory agility and streamline our processes for registration. So this past May, the three regulatory agencies announced a plan for regulatory reform. And it lists a few different things, but there were really three cross-cutting types of products that were identified: modified plants, modified animals, and modified microorganisms. GMOs, really, those are the ones that are getting hit against all the different agencies and really require us to collaborate and coordinate with one another. So for modified plants, just a couple of months ago, the White House actually released a climate resilience game changers assessment where they identified different technologies that have the ability to be transformative and really make a meaningful impact in our ability to be more climate resilient. So for agriculture, they identified two types of technologies: advanced agricultural biotechnologies, and also for our next top, they talked about precision and regenerative ag. So this is a really well put together seminar series. In the case of advanced ag biotech, they talked about different techniques like gene editing, functional microbes, and how these types of technologies can actually make a big impact in our ability to deal with drought, new diseases, and other types of stress that are related to climate change. However, that same report said that in order to have widespread adoption, in order to actually see these benefits, then clearer pathways to market and a more streamlined science-based regulatory system is required. And let me give some additional context really quickly before we jump a little bit into gene editing. So CropLife released a report a couple of years ago stating that I think for the average biotech trait, so for one insect-resistant trait in corn, you're typically looking at a $115 million price tag in order to get commercialization in about 16 years. And, because of that reason, that's why we're really only seeing these traits for insect resistance, herbicide tolerance, and it's in the major row crops, because how else are you going to make back that money? With gene editing, we have a chance to have a do-over. We have a chance to start seeing different types of traits and seeing those applied in other crops that haven't benefited from the technology yet. So far, all 3 regulatory agencies have taken the first step forward in trying to clear a path for gene-edited crops. FDA has released an updated guidance, and USDA and EPA have already released their first set of exemptions for certain types of traits that are equivalent to conventional breeding. Now, what are the next steps? Both USDA and EPA have planned and committed to expanding their exemptions for traits that could have occurred through conventional breeding. At least for EPA, we're also really have all options on the table. We're looking at expanding the exemptions, we're looking at having sort of a new approach to the exemptions, and we're also looking into ways that we can more broadly interpret our existing exemptions in the meantime in order to have a more immediate regulatory relief. So as I mentioned, you got an insect-resistant trait in corn, and you're going to all 3 regulatory agencies. Well, EPA and USDA are in active communications right now to work together to reduce or eliminate that duplicative oversight that exists in the environmental risk assessment side of things. And so what that could look like is either agreements or formalized processes where one agency defers to the other, or it could look like a situation where you still go to both, but one just utilizes the risk assessment of the other. Again, all of these options are on the table, and we're looking for ways to collaborate and to make it work. And then the last thing that I wanted to point about for the GE plants is that EPA is currently working on developing considerations documents for our plant incorporated protectant submission. So again, like insect resistant, disease resistant traits, with the idea being we've been regulating these traits for the last 30 or 40 years, and we get quite hefty data packages for those traits. But again, with this influx of technology and the very limited resources that we have, it's really time to start asking ourselves, do you need all that data? What is the data that really matters and makes a difference? And so this streamlining process not only is beneficial to industry, but really it's beneficial to ourselves as well with those limited resources. And the other goal of having these updated guidance documents is to allow greater consistency. So the other topic that I want to briefly cover today is modified microorganisms. This is a field that is very active and is asking for regulatory clarity. So one thing that the agencies have done recently, last week we just released an interactive tool for genetically modified microorganisms. So this tool provides a developer like a one-stop shop to go into and get an idea of who regulates them, which office do they need to talk to, in which stage of development that they're at. So the way that the tool works is you enter into it, and then it's going to ask you what type of product you have. Is it an ag product? Is it industrial use? And then it'll ask another series of questions to determine which regulatory pathway you're likely to trigger. So, for example, are you a plant pest or have the potential for biocontrol? That's going to be a regulatory trigger for USDA. And then eventually, once you reach the end of that tool, you should have the answer as to which regulators you should be speaking to, and also which regulators you don't necessarily need to speak to at that stage of development. So I also got a QR code up on the screen in case you want to play around with the tool. And again, I'd like to point out, so this tool is really meant to be the first step. It's just describing the regulatory system as it currently is. And I think GE microbe developers have made it very loud and clear to us that they are not satisfied with the regulatory system as it currently is in the context of GE microbes. And so with this tool, there is a built-in feedback function where stakeholders can submit feedback directly to the agencies, at least in context of usability of the tool. As I said, we know that this is the first step and more work needs to be done for GE microbes. So EPA and USDA are further working together to try to align our data requirements. One, that just can potentially make things easier for everyone if we're all speaking the same language. Two, this also paves the pathway to have data be more transferable or potentially again result in that reduction or elimination of duplicative review. And I should also note that USDA has recently issued a request for information to explore less burdensome pathways to commercializing genetically modified microbes. And so I know that they're certainly looking at that, but so is EPA to see what ideas have been generated. So my last couple of slides, I was also asked to talk a bit about myself and my job at EPA, so that's what this is. I'm originally from Lawrence, Kansas, and I got my bachelor's degree in ecology and evolution. I then did a PhD at Emory University in similar field, population biology, ecology, and evolution. I had no idea about working in policy or regulation until I became a AAAS Science and Technology Policy Fellow. That's how I got my sort of foot in the door. Jason Delborn, who's faculty at NC State, just finished his recent fellowship, so I'm always happy to answer any questions, but you've also got a great resource here at NC State. My current day-to-day job can really highly vary, so we're dealing with people bringing in regulatory submissions, so pre-submission meetings where you're providing guidance to industry, and then of course somebody actually has to review all of that data. And so I specialize in the Ecological Risk Assessment and Endangered Species Act assessments and look at it from that angle. Like I just discussed today, though, we're also doing quite a lot of domestic policy where we work with the different agencies and also internationally to, again, kind of try to push a science-based, risk-proportionate policy. A couple aspects of my job that I've always liked. So when I originally was a AAAS fellow and then I interviewed at EPA, my initial reaction to seeing the Office of Pesticide Programs on my interview list was, ew, like, what? I worked on monarch butterflies before, why would I want to work on that? But then when I came in, I actually was really surprised at how much of my basic biology knowledge I could really apply to these technologies. And it's been really interesting to see so many different types of technologies coming in. You're constantly learning and constantly evolving. And then the last thing I wanted to point out is that, regulation, I think you think of it as like, that's pretty dry stuff, but I find the work to be really meaningful and impactful because again, you can have all these great technologies and the science can be there for us to make these big strides. But if the regulatory system is not in a way that's supportive of that, it's going to hold society back. So I really value the type of work that we're doing within the US government to try to push things forward. And it also really aligns with my own personal ideals of sustainability and helping with climate change. Especially working in the pesticide office, what I like to tell people, developers, are just let me keep walking around with a superiority complex and then we're good. So with that, I'll wrap up and then I think we're doing questions at the end, right? Okay.
Thank you so much, Amanda. So yes, we're gonna hold questions to the end, and then we're gonna have all three of our speakers up here for open Q&A. So our next speaker is Gail Vegas. Gail is coming to us from Bayer.
Good afternoon. So first I want to say I'm really pleased and honored to be here today. So I want to thank you, Adrian and Kathleen, for the opportunity, and very nice to meet you, Amanda. So my name is Gail Fage. I work at Bayer. I'm in the Regulatory Science Department. And in my presentation today, I would like to share a vision. It's Bayer's vision for a radically different registration framework for CP product, plant protection product, not seed and traits, that could truly enable regenerative ag. So in my presentation today, I'm not going to give a lot of details. You can hear me, right? I don't have to speak so close, I guess. I'm not going to give a lot of detail about the vision itself and, and the detail on how it's going to work exactly and so on and so forth, because we just don't have all the answers. We'll need more brains for that and also brain from outside of Bayer. But I hope that by the end of my presentation, you will have a good understanding of why we at Bayer think that this change is needed and why we believe it will benefit the whole industry, the whole, sorry, value chain, ag value chain player, from the regulatory authorities to the farmers, the industry, and the society. So let's spend a few minutes on regenerative ag. So everybody seems to agree, more or less, today that the future of farming is going to be regenerative. There is no common definition of regenerative ag within the industry yet, but there seems to be an emerging consensus that regenerative ag should be an outcome-based production model. That means a production model focused on delivering specific results or outcomes rather than strictly adhering to some farming practices or processes or inputs. And this is sorry. And sorry. The picture. So, like most, if not all, of the big player of the ag value chain, Bayer has made regenerative ag commitments, and Bayer will support farmers produce more and restore nature by offering them system of solutions, not solutions, but system of solutions tailored, and this is basically the most important part, tailored to the very specific conditions of each and every field. And this is important because this is the condition of an outcome-based production model. It cannot be a one-size-fits-all solution because every field is different. So the question I would like to ask all of us today is, do we really think that we can be successful with our regenerative ag commitment if we really continue operating within the existing regulatory framework? And if we really believe that the future of farming is going to involve terabytes of data, capturing a lot of data, recording data on soil health, biodiversity, and agriculture practices, then I'm so sorry. If we believe that this is the future of farming, then so I'm so sorry. So the question I would like to ask is, this is the Bayer vision. So we're gonna partner with regulators and industry to modernize the regulatory processes that connect farmers to agricultural inputs. And by doing that, we think that we can really achieve two major outcomes. The first one is timely, smart, and flexible product approval, enabled by data, analytical models, and automated decision making. And the second one is tailored prescription for individual fields, giving farmers exactly what they need to do the best work, producing more while limiting the impact of what they do to the very minimum to restore nature. And we believe that the technologies are there, that it's not such a big problem, that we can do it. The question is more, do we really want that? And does it make sense to everybody? And do we want to collectively deliver that together? So what's wrong with the existing framework? There is actually nothing fundamentally wrong with it. It's just a framework that was developed decades ago and from an era where we didn't have access to data. And today we have access to a lot of data and we can do much better. So for those of you who are not familiar on how product is registered today, it's actually I'm gonna just do a little explanatory here to explain you how it works. So it's a little bit simplified, but basically it's how it works. So the regulatory authorities calculates an exposure, realistic worst case exposure value. And basically they have invented the concept of the worst case scenario because we don't have data coming from each and every field. So what they do, they modelize a worst case field and a worst case environmental compartment for which they want to conduct a risk assessment. And they're gonna come up with an exposure realistic worst case concentration, which is gonna be basically which will basically cover 90 to 95% of all the situation for the country. So what they're gonna do, they're gonna then compare that value with another calculated value, which is the toxicity threshold. And that toxicity threshold is derived from the dossier that's submitted by the registrant. And in that dossier, there is a lot of data, lots of ecotoxicological data. And for each compartment, they're gonna derive a concentration on which is also gonna be some sort of a worst case, because of course we don't have data on every species, so they will add safety factors to take into account inter and intra-species variability. And then as long as the calculated worst case exposure concentration is below the toxicity threshold, then the product is supposed to be safe, and the application of that product is then supposed to be safe, and the product can be registered. So in that situation, it's kind of the best case. Product is registered, the buyer is happy, the farmer is happy, the regulators are happy. So, but it's not always that easy, and it's not always ideal. So for that second example, which is product B, here you see that the exposure concentration is actually higher than the toxicity threshold. And in that case, the authorities basically have two options. Either they say, well, sorry, Bayer, your product cannot be registered and we cannot put it on the market and farmers can't access it. Or they say, well, we have a problem here, but in fact, if we apply mitigation measures, then we can significantly reduce the exposure values. And in that example, now the new calculated exposure value is below the toxicity threshold, and then the product can be registered. But every farmer that's going to use that product will have to implement those mitigation measures. And mitigation measures sometimes are very unpractical or very expensive. But now if we come back to the left part of the graph, what really happened in that situation, the part which is now highlighted in red, this is really the part where indeed it probably makes sense that those farms for which the exposure concentration is actually higher than the toxicity threshold would implement those mitigation measures. But for the ones which are actually in the green area on the graph now, in fact, from the beginning, the product can safely be applied in those fields, and there is actually no need for those mitigation measures. So this is just to kind of explain the limitation of the current system, and why we think that if we have access to so many data nowadays, we can do actually much better. And now this is really a vision of what we think could be done in today's world when we have access to so many more data. So on one hand, if the product intrinsic property could be registered and certified by the authorities, this includes the endpoints and the toxicity thresholds that would be really relevant to one specific product. Then next to that, we can have access to field-specific data coming from each and every farm or field, including soil data, including weather data, including pest pressure, including the surrounding areas where you could see water bodies or little rivers, whatever. Then, and under the condition that the algorithm and the model would be also, of course, certified by the authorities, then we could run the risk assessment at the field level. And then every outcome, every prescription that would come out of this risk assessment would be the new product approval. And it would only be valid for that field at this point in time. And this, we think, would really allow tailored prescription, giving really farmers what they need to do their best work and produce more, while at the same time limiting the impact of what they do to the very minimum and restore nature. And when this is all digital, then on top of that, of course, it could theoretically be automatically executed by machinery in the field. And if it can be automatically executed by the machinery in the field, then it also becomes much easier for the regulatory authorities to enforce the prescriptions. So with that said, that's the end of my presentation, and I'm very happy to ask some questions later on. Thank you.
Great, thank you so much, Gail. So our last speaker is Dr. Denisha Seth-Carley, who wears many hats. Her hat she's wearing at the moment is she is going to be representing our Center of Excellence for Regulatory Science and Agriculture.
Thank you, thank you. Howdy, everybody. For those of you who don't know me, you will by the end of this talk. You're welcome. So as Kathleen said, I wear a lot of hats. I'm faculty in the Department of Horticultural Science here. I also did my PhD and my postdoc here at NC State. I'm a proud Wolfpacker. And I also lead 2 centers. So I'm only allowed to talk for 15 minutes. So I'm only going to talk about 1 center today. But catch me afterwards and I'll talk to you pretty much about anything you'd like to. But today I have to stay focused on a relatively new center. In fact, we were just branded a formal center. Was it last month, maybe? Yeah, last month, formal center, even though we've been working very hard behind the scenes. The hamsters have been running to get the center off the ground and for the last 5 years. So thanks to Adrian and everyone else who was part of that to get us going, but we are now officially a formal center, and we call it CERSA because otherwise you fall asleep before you get to the end of the name. All right, so again, with only a limited amount of time and probably your attention, I want to make sure that I'm focusing the talk on what is most germane to our center, CERSA, because I would like for you to not only get to know me today in the short time we have, but also, and most importantly, get to know CERSA. There was a large group of folks who were very focused on the need for more regulatory science in agriculture, sort of centric programs, and they all came together. This is before my time with CERSA and before CERSA was even a thing. And they all came together for a workshop and they talked about sort of what does this look like? How do you do something sort of this audacious? How do you tackle the federal regulatory bodies in a way that's approachable and can essentially make change eventually or in some fashion? And the idea was that whatever that looked like, that group, that body, that now center, right, needed to make sure that they were raising awareness to our communities about regulatory challenges. It's easy for me to talk to you guys about regulatory science and the importance of regulatory systems in our communities because you guys have all been touched by that in some way. But I'm also an ambassador for regulatory science. In fact, I leave tomorrow to go to Scotland to give a talk on the importance of regulatory science in agriculture because the industry that has asked me to come speak was sort of blown away that we had something like this here. And we're the first and only, I always say in the United States, but it could be the world. I don't know. They'll tell me next week when I'm in Scotland, when I give this talk and say, we're the only one in the world. If anyone stands up and says, no, we do it too, then I will have to amend my talk and I will come back and I will mea culpa. But we're the first of its kind and we're very proud. So again, I'm an ambassador, not just within the regulated community and within the regulating bodies, but to everybody whose lives are touched by agriculture. We should also increase cooperation and collaboration among stakeholders, and that means everybody. And I'm going to tell you who that is in just a minute, but essentially I'm going to also say that includes everyone in this room, again, everyone who's touched by these regulations. and obviously address important challenges in the regulatory field in an unbiased manner. And I think that's why they came to NC State. We're an academic institution. We have very sound scientific background. We all believe that science is the way to make decisions, and we agree on that. And so we can help facilitate these conversations, again, on neutral territory. And then ultimately, and actually, although this is my fourth point, this was the first thing that came out of this conversation, was that there are not enough regulatory scientists. A lot of people had the same sort of sense that Amanda did right out of the gate. I did too, right? So I'm not trying to throw you under the bus, but you know, people are sort of like, well, what is regulatory science? I don't know what that means. And there are no other programs in the whole country that teach people how to do regulatory policy, regulatory science in agriculture. And so our charge was essentially to help train the next generation, or help Amanda fill those very important positions in the federal government, in industry, at NGOs, and beyond. All right, so CERSA was born, right? We're sort of talking history now. As of last month, we're officially a full-fledged center. And what does that look like? So we were charged with doing all of these things. We have included partners that are academic partners from universities all over the United States and actually beyond. We, of course, work with the federal regulating agencies, but we also work beyond them as well. With other federal agencies, we work with a lot of industry partners, a number of whom are in the room, so thank you all. NGOs and other stakeholders, grower groups. We work with people on Capitol Hill, you name it, we talk to them. I'll talk to anybody, right? But essentially the goal is to bring folks together, again, to advance regulatory science. We were born on the same three pillars as our land-grant universities, and that is research, education, and we call it engagement here at the land-grant. Of course, we call it extension, but it's the same idea. And the goal, of course, is to advance regulatory science in ag. So I'm going to give you just a snapshot. I don't actually have, you're just going to have to wave at me when it's time for me to stop talking, and I'll stop talking because I don't have a watch or anything that tells me what time it is, and I can talk all day. So I'm just going to talk to you a little bit about each of those three pillars, and then I promise at some point I will wrap up and let you guys go have your snack. But the first thing that we were asked to do is to get an educational program off the ground. And Keith, I think I saw Keith. There's Keith. Thank you, Keith. Shout out to Keith, who runs our undergraduate and graduate certificate program for CERSA. There was literally no playbook to go by. So Keith, along with a lot of other very smart people, got together in a room and said, what would that look like if we were teaching a regulatory program? What do the students need to hear? Who do they need to hear from? Because Keith is an incredibly intelligent human being, but does not know everything about regulatory science from one end to the other. And so we had to think about, what does it look like? What do the students who are coming out of these programs need to know? And Keith runs that program and has very successfully for the last 5 years. So that program was the first core pillar of CERSA. We've since expanded. We now have an internship program. I'll talk a little bit more about that later. We do a lot of workshops, and a number of you have been in the room with us while we are working on those workshops. Again, I'll talk a little bit more about that in a moment. I was drug kicking and screaming into the international space. I was not ready. I was like, look, we've just started. Let me get my feet on the ground. Let me understand what this is. Because y'all, I am not a regulatory scientist. I did not come from a regulatory background. I'm just a yes person. And so I said, yeah, that sounds like a lot of fun. So I took on this project, and everyone was like hitting me with all these things. Because, you know, like I said, there aren't any other programs like this. So again, there was no roadmap. And I was like, I'm not ready to expand into the international space. So whether or not I liked it, and within 3 years, we were now working in the international space. And I'm not going to talk about that. You can ask me about it when I'm in the hot seat, because I don't have enough time to talk about those programs, but we also do international workshops and trainings as well. And then we also host short courses. Okay, goodness gracious. All right. So here are just a couple of pictures from some of the programs and from some of the interns with whom we've worked. You can see it's just, well, you can't really tell from the pictures. You'll have to take my word for it. It's an amazing group of people that we get to work with. Just in August, because I am an overachiever, I hosted not one but two regulatory workshops back to back. So for 20 days, I spent immersed in the field talking with regulators from all over the world. Thailand, I don't know, Mexico, Gambia, Namibia, there are a couple others that I'm forgetting. Brazil, thank you, Costa Rica. Thank you. Adrian pays attention better than I do. But I was with them 24 hours a day talking about regulatory science, talking about how the US does what it does. Amanda spoke at one of our workshops. A number of people in this room, Rodolph, spoke at one of our workshops. And, you know, it's a team effort, but essentially everybody leaves with a very sound understanding that our regulatory science is based in factual science, is data-driven, and we really know what we're doing. And so they should, you know, trust us. We're from the government. We're here to help, right? But I'm really proud of these programs, and it was just so much fun, and it was exhausting. And Laura, don't let me do two back-to-back next year, okay? Something else that we do, and I mentioned, is that we hold a lot of workshops. We hold anywhere from 1 to 2 workshops a year. This is in addition to everything else that we're working on. The goal is to tackle a challenge in the regulatory field. And we tend to put out a call to our CERSA community, and we say, hey, what are some of the regulatory sticky points that you guys are facing, and a challenge that you might like to see us help you tackle? And then we literally sit down with folks at the EPA, USDA, FDA, depending on who our regulating body is, and we say to them, which of these topics would you be willing to work with us on? Where do you need help moving the needle? Where would you like to see us workshop this topic together? And this was the very first workshop. And again, there are folks in this room who helped get this workshop off the ground. It was apparently a tremendous success because people keep coming and asking us to do more and more workshops. And because I only have 15 minutes, I'm going to very quickly skip all the way until last year, where we held something like 4 workshops last year, 2 this year, and here are just a smattering of the topics for the workshops that we've worked on. You heard Amanda mention earlier that the EPA and the USDA are working on this new regulatory policy for genome-edited microbials in ag. They've been literally in this room with us workshopping this topic, and so I know that we're at least working to make big strides there. And because they're so interested, we've had 3 workshops on that particular topic, and we're getting ready to write a cast paper on it. So big things come out of these workshops. It's really exciting. We also did a precision application of pesticides, and then we just held one on reducing the exposure of aquatic organisms to pesticides in Brazil. And I'm already hard at work at my next workshop next year, because 2024 is almost over, and I've already done something like 4 this year. So if you're interested and you haven't heard about our workshops and you're interested in participating in one in the future, just grab me afterwards and I'll make sure you get signed up to hear more about it. All right, I promise I'm wrapping up. So the third pillar, we've just touched on this, and actually Gail already introduced this topic. We're working with them on their project. How do we help growers make real-time risk assessments on fields in real time? And so this is our first program effort under the research pillar, because we've been focused on education and outreach for the last 4 years. And now we're just dipping our toe into how can we develop research together to, again, help move the needle. We want to make sure that growers have the ability to be facile and use these the environmental data of their field and their cropping system to help them make better management decisions. And Gail, I had a whole bunch I wanted to say about it, but knowing that you just talked about it and we're building on what you were talking about, I don't want to steal any more thunder from that program. But, you know, essentially, I see regulatory science as contributing to, and you can say anything you want here in the brackets, agriculture, right? So back when I came on as a postdoc, we called it sustainable agriculture. And then there was a lot of discussion about, well, what does that mean and how do you define it? And then now we're calling it regenerative ag. I was just in a coffee field with growers from Costa Rica and they were calling it climate smart ag. It doesn't really matter. You can take all of those buzzwords out and just think about it in terms of regulatory science contributes to agriculture, right? We're all here because we want to be more sustainable or more holistic or do a stronger job of protecting our resources, our growers, our economics, right? And so regulatory science contributes to these guidelines and helps us to ensure safe practices, make sure that our soil is protected, our pollinators are protected, our ecosystems are protected. But also, and I want to just bring, I know I'm running out of time, I just want to bring it to that third bullet point, which maybe should either be my first or my last. But I think it's really important also that we help to build consumer trust and grower trust in our systems, right? And again, that comes back to sound science and data-driven management and management decisions. And ultimately supporting innovation, making sure that anything that we're putting out there, whether it's biotech crops or new technologies for pest management, is ultimately safe. And I know that that space is a little bit challenging because we are innovating faster than the regulatory policy can keep up. But the regulatory groups, and you heard this from Amanda, and I heard this from all the regulating agencies that we work with, that they really do want to help make sure that everything is safe, but also innovations are able to move forward. And we work in that space, so it's really fun. And then lastly, I just want to close on, I'm supposed to tell you these things, right? Oh, if you want to get involved, these are the different ways that you can get involved. But really, you can read that if you want to, and I'm not going to tell you any more about it. I just want to brag on my interns for a very short moment. We've had something like 15 regulatory interns come through our program, and it is one of my very favorite parts. Don't tell anybody, right? It's just between me and you guys. Don't tell anybody else. Working with the students is one of my very favorite parts of this program. And we have donors who have given quite a bit of money so that we can run this internship program. Essentially, students apply to the program out of Keith's program into the CERSA mentorship program. We ask every year for mentors, and again, there are a number of folks in this room who have been mentors for some of those students. And the students embed with those teams for 3 months. Last year, I had a student that was so interested in her program that she refused to leave, and she stayed for 6 months in her program. And I just love that. She was like, no, I'm having too much fun. This is too great. But eventually they do leave and move on to great, wonderful things. But I always get such wonderful feedback, not just from the students, but from the mentors about they're getting to work with these students who are fresh-faced and eager and now very well educated in regulatory science, which is new, right? And so they go on to do wonderful and amazing things. I get text messages from them. We sometimes, when they have the chance, they go off to conferences. I sent one of our interns last year to Spain to Minor Youth Foundation Summit. She was sending pictures back. She had so much fun. And the people that she was meeting, it was just amazing to see her with all these people. And I was like, man, those people that you're talking to are very important people. Do you know how important they are? And she got along great. She was able to talk with them. And she was just so proud that I just every day at odd hour, 3 in the morning, I would get a picture from her, which was fine. It's fine. It's great. And I just got an email this morning from one of our former interns who was she just wanted to drop me a note and say, oh, I got a job thanks to the internship. And I just wanted to tell you how much I appreciate having that opportunity. So I'm not going to talk about anything else other than if you're interested in hosting an intern, we do pay the students. We do all the heavy lifting, all the paperwork. All you have to do is do the mentoring, which I realize is hard enough on its own, but we will match you with the right student if you are willing to give one of them a chance. And with that, I will stop talking. Kathleen, it's all yours.
You're going to the seat.
I'm going to get my water.
Okay, you get your water. Thank you so much to all 3 of our speakers. Those were excellent talks. So now we want to give you a chance to give questions and they will answer. So we'll have the 3 speakers come up to the hot seats.
There's little switches on the side to turn the mics on.
Yeah. And so for about the next 10 minutes, you're welcome to ask questions.
I haven't been drinking.
Yeah.
My question is for Gail. Can you give an example to like illustrate how a particular field, what data from a particular field would change whether or not it's above or below the toxicity threshold?
So the exposure needs to be
The exposure.
the exposure level, which is really based from the condition of how the product is applied and also related to the field itself, can be the soil type, organic matter content in the field. There is a lot of different elements that will actually impact the exposure concentration in the different compartments that are used to make the risk assessment. So if you take, for example, surface water, not every field has a big river next to it. However, today we take risk assessment, this worst case scenario, which I try to explain, and we make the assumption that next to the field there will be a pond, and the pond is a worst case pond, which are is this characteristic. Well, in fact, there is not a pond or a river next to each and every field. So this is really why, depending on each situation and each field, the exposure concentration is going to be always different in the different compartment where we run the risk assessment. Does that help?
Yes, thank you.
Thank you.
Or Gail or Amanda. I understand it would be really good to have very specific labeling for a specific field in a particular situation. I'm not quite sure how to put that on a label. And do you have some ideas on how to do that?
More about this.
So again, as I said in my little talk, we don't have all the answers, right? But we have some ideas, but we don't have all the answers. So, but to your question, the whole point is that there won't be any, we won't have the need for those static labels anymore, because the outcome of the risk assessment will be in the form of a, I want to call it label, this is why I call it prescription, that's going to be just valid for that field at that point in time. So in our future desired states, in fact, we won't need those strict labels anymore, static labels.
I think this question is, well, I wrote it for Amanda, but I think everybody could probably answer it. Has EPA considered a set of standards or like a voluntary certification for ag products to show that they're sustainable and define what sustainable means and then the data behind that so that consumers can look at a label and think that this might be a better choice? I'm thinking kind of like safer choice on the cleaning side of things, but for ag.
Well, funny you should ask. I just started hearing rumblings about such a thing. I don't, probably quite a ways off, but I think it's a great idea, especially these types of products that are environmentally friendly alternatives, to find a way to put that on the label and to make that clear to consumers that, this is a product that's a little bit above and beyond the normal criteria that's met.
May I comment? Just on your question, right now, some products, EPA review them and provide them with like reduced risk. So they will consider a particular product as a reduced risk product. And I do not know if they are sitting on the label that says reduced risk, but you can check that and you can see what product received a reduced risk, decision by the agency.
Thank you. Yeah, my question for the Amanda. So when you say that genetically modified, so what's the basic criteria you use for the genetically modification? So like, is there any limitation for about the number of the bases in the case of the insertion or deletion?
That is the question that everyone is trying to answer. So, the US government as a whole has sort of come up with their first try for plants, what GMO versus gene editing means. And right now people have 3 different answers from 3 different agencies. So I think we're working together, we're trying to work together more to make it so that one country doesn't have 3 different answers. But I think with genetically engineered microbes, we've got another opportunity to again take a look at that and maybe try to get it right together the first time. But of course, that has a whole other host of considerations on a science perspective. What does it mean with a microbe that might have a lot more horizontal gene transfer and whatnot compared to plants?
And my question is also for you, Amanda. So you mentioned you have the Endangered Species Act under your purview, so I have to ask you. So I think industry, of course, has seen some longer review timelines recently due to ESA evaluation. So wanted to ask what's sort of next for the ESA and what might industry do to help provide more data information that might make those reviews easier by EPA?
Yeah, great question. So, again, leaping back to that whole superiority complex feeling, at least in biotech, we're largely able to still just make no effect findings under ESA just by the nature of the products themselves allowing for that. I know the strategy for biopesticides as a whole, we're also really, ESA is not a risk benefit statute or, law like FIFRA is. But we are trying to leverage the benefits aspect of biopesticides. And one of the things that is sort of the new requests that developers can help with their larger biopesticide applications is to really provide that benefits information to sort of help paint the picture of the future world that could exist where your product is registered and it is providing benefits to non-target organisms, including endangered species, compared to current options.
So the concept that Gail introduced about having custom prescriptions for certain fields is very intriguing, and I could see that being interesting for the future. Do you think that would necessitate, or to say another way, is the current data package of a regulatory dossier sufficient to allow for that? Would you have to then maybe in the future collect more residue degradation data in different situations to model that what you're talking about, or maybe even as a new registrant to suggest new non-guideline studies to situationally show under what circumstances the degradation would reduce below that toxic threshold?
So that's a very good question. I think we could actually do field level prescription based on the current data that we generate and submit. We could use, in fact, in theory, the very same model, but just use, instead of input parameter, instead of using the worst case scenario, we could use use the data coming from each and every field. That being said, that would be a first level. But I think if we can do more research and then really better understand under which condition our product works better, depending on soil type, depending on, temperature, pH, whatever, then we could even tailor the recommendation so that not every field would have to apply the same dose rate. Today we have a dose rate. I mean, I think in the US you have a little bit more flexibility. You have one dose rate which is registered, and there is flexibility to go below. In some countries, you don't even have that flexibility. In France, for example, there is one dose rate on the label, and every farmer has to use that one dose rate. It's not allowed to go higher, it's not allowed to go lower. So in those countries where, well, if we could have the flexibility to go lower, which is the case in the US, you could also tailor the exact dose rate that would be the minimum one, which would actually be enough for that field. And then you can really go in the direction of, as I was saying, restore nature, produce more, but still, improve and restore nature. So I think we can do more science to really better understand the best conditions that really makes our product work the best, right? And then include that in the algorithm that delivers the prescriptions.
Good idea. Should know how these work by now. I also think this whole idea is really intriguing, and I kind of liken it more simple version, if you like, of drones that are not allowed to fly into restricted airspace and will automatically down themselves if they stray into an airport or whatever. This is more complicated, but it feels to me like we have a lot of the technology now available to pull all of this together, from soil mapping to the toxicity and ecotoxicity data to the precision application machinery that we have. And from satellite data, all of this stuff could be integrated, but it's also very, very complicated. And so to make this happen, Gail, I'm wondering what you envisage as kind of next steps, and who would be involved in trying to, ultimately, move this forward, because it's not something that's going to happen overnight, clearly.
I agree. And in fact, George and I were discussing about that earlier this week, how to proceed and how could we convince, because Bayer cannot do that alone, right? It's very clear. And if the regulation change, it's not going to change just for Bayer. So we need to partner with the industry, and that's going to be probably the first step. And partner, once we have hopefully an agreement that this is the right direction that we should go as an industry, we'll need to make sure farmers also agree with that and understand the value that could benefit for them. So that could probably be the next step. And then after that, we have to go maybe talk to, the policymakers and what do we need to change to make that happen? That's kind of where we are.
Two more questions?
Rakesh Ranjan from BSF. And this question for Amanda. So when we were talking about genetically modified or engineered microbials, so for currently, if I understand correctly, for BT microbials, there is no, so they have tolerance exemptions. Will this apply also to G microbials or not?
Oh yeah, so I mean, I think the majority of biopesticides, I can't really think of one that doesn't get apply for tolerance exemptions. And we have GE microbes that we're already looking at, and there's no expectation that they wouldn't receive a tolerance exemption, assuming they, meet the dietary safety requirements. So yep, there's definitely no standard just because it's GE versus non-GE.
Any other comments or anything? All right, thank you all so much for coming, and thank you so much again to our three speakers. Let's give them another round of applause. All right, from here, we would love to invite you to come on up to our main lobby. We have some drinks and some snacks to share with you all, and then we can network and get to know each other better. So thank you again so much for coming.